Okay, now look at example 3 with me, okay? Here, example 3, we have an equation, and that is R. R stands for the resistance of a band, and R equals 3 over 8L. L stands for the length of the stretch band when you do exercise, you know. Okay, so this is the relationship between the resistance and the length of the band when you do your exercise right here. Okay, now, for some reason, you want to find the inverse of the model, meaning, can you find the value L being written in terms of R? Okay, so this is the function. You think of y equals 3 over 8, x minus 5. And now you want to find what? That's right, the inverse function, which is, there we go, or in this case, what? That's right, R negative 1. Okay, I said that the inverse of that, which is solving for what? Solve for L. There we go, solve for L. Okay, the technique to solve for L is right here. Okay, here we go. I mean, you are no stranger to this right here. Can I bring a negative 5 over? There we go. Negative 5 over. So what you have over here? Now you got R plus 5 equals what? 3 over 8 L. Almost there. What's the next one? Solving for 8. Solving for L. What did you do? Yep. You time both sides by 8 over 3. Okay. Time both sides by 8 over 3. And that will give you L alone. Okay. So now you have L equals right here. Okay. Let's just time them in. This 8 times R is 8R over 3. 8 times 5, okay, which 8 of them, that will be 40 over 3. There we go, guys. This is what you have right here. Okay. The next thing they told us that, well, if you have 19 pounds of resistance, okay, if R equals 19, then what is the length being stretched? If R, right now, if R is, they say 19 pounds, okay, 19 pounds right here, what would the length being stretched? Plug it in. L equals 8 times what? 19. Okay, you see it? Over 3 plus 40 over 3. And then, guys, you are the expert for this right here. And the answer, the outcome will be 192 over 3, which is 64. There we go. This brings you to a very famous formula of temperature, which is Celsius is written in terms of Fahrenheit degree, which is 5 over 9, and Fahrenheit minus 32. There we go. Okay. This is also a function, and you can find the Fahrenheit degree in terms of the Celsius degree. Either way. All right. Now I'm moving into a very significant concept, and that is the inverses of nonlinear functions. What would that look like? Now, go on with me. Let me give you a very fancy concept of inverse function. How do you guarantee? How do you guarantee that a function has an inverse function? What that means, what I just said is huge, guys. And that is not every function has an inverse function. There we go. Until or unless you set boundary or you set domain condition for the independent values. For example, here we go. For example, okay, if you have a function f of x equals x squared, okay, f of x equals x squared, okay, what would the graph looks like? Looks like this right here, okay? This is a function because I know why. Because it passes the, that's right, it passes the vertical line. Got it? To be a function, for a relation to be a function, it must pass the vertical line. Okay, got it? Now, for a function to have an inverse, that's a key thing I just said. For a function to have an inverse function, that function must pass the horizontal line. There we go. In a moment, I'm gonna demonstrate that to you real quick. But look at this right here. This guy right here, f of x, is x squared. I'm just giving you a function, and this is what the graph looks like right here. Okay, there we go. The graph looks like right here. All right. Now, you want to find the inverse function for me, which is y equals x squared. This is the function. F of x is y, equivalent. Okay. Look, I want to find the inverse of this guy. Okay. Solve for x for me, which is finding the inverse right here. What is the inverse? Okay, we just solve for x. What do? You take square root both sides. So now what? X equals what? Positive or negative y right here. There we go. You see that? Okay. Now, this is key for you right here to say, okay, Mr. Dan, what shall we do right here? Okay. Oh, I am using from the example. Oh no, they want to find the inverse right here. Wait. Here you go. This is the x squared, and in your textbook